Case study, Revolutionizing Cyber Defense, CyberShield Inc.'s exploration of semi-supervised learning in mitigating modern cyber threats. With the ever-evolving landscape of cyber threats, semi-supervised learning is becoming a linchpin in modern cybersecurity strategies. At the heart of this innovation are efforts to efficiently utilize both labeled and unlabeled data, a necessity in environments where labeled data is scarce but unlabeled data is plentiful. This case study delves into these concepts through the practical experiences of a cybersecurity team at CyberShield Inc., a mid-sized enterprise navigating the complexities of modern cyber threats. CyberShield Inc. faces the daunting challenge of protecting a network used by thousands of employees and clients globally. The team is led by Dr. Anna Rivers, a seasoned expert in machine learning, and includes James, a data scientist, Laura, a cybersecurity analyst, and Tom, a network engineer. They aim to implement a semi-supervised learning model to bolster their network intrusion detection system. The team begins by reviewing their existing NIDE, which relies heavily on signature-based methods. This system struggles with detecting novel threats, as it can only identify known attack signatures. How can CyberShield ensure their NIDE-S adapts to new and sophisticated attacks? Dr. Rivers proposes a semi-supervised learning approach to enhance the system's ability to detect these threats. She explains that by integrating historical attack data with real-time network traffic, the system can better adapt to evolving threats. James and Laura gather labeled data comprising known attack patterns and a vast amount of normal network behavior data. Their goal is to train the model to distinguish between benign and malicious activities. James points out a potential issue, the quality and representativeness of the unlabeled data. If the network traffic data doesn't represent the actual distribution of activities, the model's performance could degrade. They decide to pre-process the data meticulously to ensure it is both representative and diverse. As they progress, they encounter another challenge, overfitting. Given that labeled data is limited, the model risks adapting too closely to the training data, reducing its effectiveness on new inputs. How can CyberShield mitigate the risks of overfitting in their semi-supervised model? Laura suggests employing techniques such as cross-validation and regularization to enhance the model's generalizability. They also decide to augment their labeled data with synthetic examples generated from the known attack patterns. Meanwhile, Tom, responsible for the technical deployment, raises concerns about computational complexity. Semi-supervised learning algorithms typically require more computational power due to the additional processing of unlabeled data. Is CyberShield equipped to handle the increased computational demands? The team explores scalable solutions, such as cloud-based resources and more efficient algorithms, to balance the computational load. Another application of semi-supervised learning at CyberShield is in malware detection. The team deals with an ever-expanding database of malware samples. Traditional methods struggle with the rapid emergence of new variants. How can CyberShield ensure their malware detection system remains effective despite these challenges? By leveraging a small set of labeled malware samples along with a large corpus of unlabeled data, the semi-supervised models can generalize better and detect previously unseen malware strains, thus maintaining an edge over emerging threats. James also examines the potential of semi-supervised learning in phishing detection. Phishing attacks are evolving, making it difficult to maintain an up-to-date labeled dataset. How can semi-supervised learning improve the detection of new phishing attempts? By combining a small labeled dataset of known phishing emails with a large amount of unlabeled data collected from email traffic and web browsing, the model can adapt to new phishing tactics more effectively. This integration enables the detection of sophisticated phishing attempts that traditional methods might miss. In parallel, the team explores user authentication systems. Behavioral biometrics such as keystroke dynamics and mouse movements are proving to be effective for continuous authentication. However, labeled data for these behaviors is challenging to obtain. How can CyberShield use semi-supervised learning to enhance the robustness of their authentication systems? By learning from a limited set of labeled behavioral data and a more extensive collection of unlabeled data, the model can improve the accuracy and reliability of user authentication, thereby preventing unauthorized access. Despite the promising results, Dr. Rivers emphasizes the importance of interpretability in their models. In cybersecurity, understanding the rationale behind a model's decision is paramount. How can CyberShield ensure their semi-supervised learning models are interpretable? The team decides to focus on developing explainable AI methods that provide insights into the model's decision-making process. This transparency allows cybersecurity professionals to understand and trust the model's outputs, making informed decisions based on these insights. As the team integrates these solutions, they reflect on the lessons learned. They realize that the quality and pre-processing of data are critical to the model's success. Ensuring that the unlabeled data is representative of real-world scenarios is essential to avoid performance degradation. They also recognize that computational resources must be carefully managed, and scalable solutions should be in place to handle the additional demands of semi-supervised learning. Moreover, they acknowledge the importance of mitigating overfitting through techniques such as regularization and data augmentation. These methods enhance the model's ability to generalize from limited labeled data, making it more robust against new threats. Finally, they emphasize the need for interpretability in their models, as understanding the decision-making process is crucial for trust and accountability in cybersecurity applications. In conclusion, CyberShield Inc.'s experience with semi-supervised learning underscores its potential to revolutionize cyber defense. By effectively leveraging both labeled and unlabeled data, they enhance their capabilities in network intrusion detection, malware classification, phishing detection, and user authentication. Key considerations such as data quality, computational demands, overfitting, and interpretability are critical to the successful implementation of these models. As advancements in semi-supervised learning techniques continue, CyberShield is positioned to stay ahead of evolving cyber threats, safeguarding their digital infrastructure and maintaining the trust of their clients and stakeholders.